Okay, where was I? Let me zoom this up a little bit so you can see it a little bit better. 43 degrees equals 1/2 of 32 plus 1/2 of x. All I did was distribute this 1/2 and the 1/2. Could I have multiplied both sides by 2 to get rid of it? Yes, but I'm just doing it this way to show you that we're literally taking 1/2 of each part. 43 equals 16 plus 1/2 of x. Subtracting 16 from both sides, we get 43 minus 16 is 27. Equals 1/2 of x. Well, 27 equals 1/2 of x. Now I'm going to multiply both sides by 2 to get rid of the half. So I could have done it earlier, or I've chose to do it now. And 2 times 27 is 54, which we knew that's what that arc was from beginning. Okay, so this is when it starts to get a little bit crazy. Now we're going to go on to the last thing for today. This is the new stuff. So everything up to this point has been a little bit of a review. And I wanted to make the video in 2 parts. Okay. So now we're going to deal with angle formed outside the circle. So when we started at the central angle, the arc and the angle were exactly the same. Then when we moved from the center onto the circle, we ended up cutting the arc in half, or the angle was half the arc. And then we said, okay, we're going to be somewhere in the middle. So then we ended up taking an average. Now we're going to go from the center away from the circle and even further away to this angle way outside of the circle. So yes, it's going to get smaller and smaller and smaller. The further away, the longer we extend this radius, the smaller this angle out here is going to be. Okay? And this is basically the same formula, but this time we're going to say the angle equals 1/2 the big outer arc minus. It's going to get so small that we're not taking an average anymore. We're going to subtract them. Same exact formula, except for this time we're going to subtract. Why are we subtracting? Because we're getting smaller and smaller. Okay, so here we go. If you look at this example, I said the big outer arc. Because we're subtracting, we always want to make sure that our inside the parentheses is going to be positive, because we can't have a negative angle. So we're going to take the larger outer. When I say outer arc, the furthest one away. So if this is 240, that's my big outer arc, minus the inner arc. The inner arc is simply what's left of 360, right? You're going to need that later on. So we subtract 240 minus the 120, the big arc minus the little arc, and take half of it. So 240 minus 120 is 120. Half of 120 is 60 degrees. So this measure of angle ABC, this angle right here is going to be 60 degrees. Now, there's a note down here. This is kind of important. It might make it a lot easier if you can apply it. If you can't remember it, it's okay. You can always find it this way. We haven't proved it yet, but it can be proven that the measure of this ABC, this 60 degrees, and the central angle of AOC, this central angle right there is supplementary. Hey, doesn't this kind of look like that quadrilateral thing that we had going before? Opposite angles are supplementary. We know if this arc is 120, the central angle has got to be 120. And then we kind of put it together with the other theorem that the angles in a quadrilateral, the opposite angles are supplementary. We could have simply said that 180 minus the 120 is equal to 60 degrees. Kind of like a shortcut, but it's also an application of something that we've learned earlier. But what I want you to focus on is the new formula. The angle equals 1/2 the bigger outer arc minus the smaller inner arc, and that's basically it. Now there's 3 different ways we can look at it. We can use 2 tangents that touch the circle in exactly one spot. It still gives me this outer angle. Or we could use 2 secants. A secant is simply a line that cuts through the circle on the inside to the outside. 2 secants. It's still this big outer arc of 100 degrees minus the smaller inner arc, 30 degrees. And we're still simply just taking 1/2 of it. So this CAE, this angle out here that we've been looking at, is nothing but 1/2 100 minus 30. 100 minus 30 is 70. Half of 70 is 35 degrees. But this angle sticking out here, A, or CAE, is nothing more than 35 degrees. Same exact formula, just 2 different ways of seeing it. You can have 2 tangents, or you can have 2 secants, or you can have a combination, a tangent and a secant. And that's what we're going to look at here. Okay, so let's look at the tangent and a secant. Okay, so this time we have the tangent. Now this tangent could have been extended. It doesn't have to be, but it can be on the outside and then through the inside. Outside is a tangent to the circle, touches it exactly one spot. A secant goes through the circle and it touches the circle in 2 spots. It's kind of like a chord with an extension or an auxiliary line, but it's called a secant. Okay, so the measure of angle BAD, BAD, is formed. BAD is formed by the tangent in the secant, and the formula is exactly the same, 1/2 the difference of the intercepted arcs. Okay, and I always like to put it in order of the bigger minus the smaller. So this is your smaller, and this one is your bigger. So basically 1/2 of 164 minus 70. 164 minus 70, when we subtract them we get 94. We take half of it and we get the measure of BAD is 47. Okay, so basically it's exactly the same thing we were doing last time, except for this time we're subtracting. Why are we subtracting? Because we're getting further and further and further. We're not even in the circle anymore. We are outside of the circle. Okay, so here's some examples of what I did today. This is the 2 tangents. So I'm going to write 2 tangents. These are 2 secants. So this problem happens to use 2 secants. And this one would be the one with a tangent and a secant. Remember here before I said we can just touch it or we could extend it further. Either case is okay. So this would be a tangent and a secant. And this is a special problem with 2 secants. This is like on your homework. So this would be kind of a homework question. All right, so let's go ahead and let's focus in so we don't miss anything. So let me move this up a little bit. And let's apply it and let's go. All right, so the formula is this angle is equal to 1/2. I'm going to call it big arc minus small arc. Take half of it. This time they're giving me the angle. So we can simply plug it in for what we know. The angle is 5x plus 17 equals 1/2. This time they're going to give me the big arc, which is simply 37x plus 5 minus the inside angle, which is 23x minus 5. Okay, now be very, very careful. This is subtracting, and it's subtracting both of these terms. So you're going to have a sign change because a negative and a positive is a negative 23x, and a negative is going to be a positive 5. And this is 37x plus 5. Remember, we're taking a half of it, and that's going to equal 5x plus 17. All right, so what I want you to remember is that when you're subtracting, especially subtracting this binomial, that you're going to have to distribute to both terms. All right? Then we end up with 37x minus 23. Well, 37 minus 23 is going to give me 14x. 37x minus 23x, when I combine like terms, gives me 14x. And this is a negative, this is a positive 5 and a positive 5, which is going to become 10. That's positive 5. And this negative and negative became a positive. So that's plus 10. And we're going to be taking a half of it. I'm going to move the half to this side because I'm running out of room. 5x plus 17. Okay, so I can get rid of this half by multiplying both sides by 2. It's 2 times 5, which is going to be 10x, and 2 times 17, which is going to be 34, equals, when I multiply this side by 2, it cancels it out, and I simply get 14x plus 10. Subtract 10x from both sides. We get 34 equals, this becomes 4x plus 10. Subtract 10 from both sides. We get 24 equals 4x, and x simply equals, after all that, 6 degrees. Okay, so I picked some harder problems because I wanted you to see it's nothing but plugging it in and remembering all the math. All right, same exact formula, different looking problem. Angle equals 1/2, big arc minus the small arc. All right, so this time what are they giving me? Are they giving me an angle? Sure they are. And what is it? Yes, 15x. 1/2. What is my big arc? And it is a biggie, isn't it? The big arc is 55x minus 2. Minus 48 degrees. So 1/2, 55x minus 2 minus the inner arc, which is 48 degrees. All right. Do what's inside the parentheses first. 55x minus 2 minus 48. When we combine these, we end up with 55x minus 50. 1/2 equals 15x. Let's get rid of the half by multiplying both sides by 2. And we end up with 30x equals, these cancel out, 55x minus 50. Subtract 30 from each side. And move the 50 to the other side. It's negative, so we want to move it over here by adding 50. And 55 minus 30 is 25x. X simply equals 2. Okay, I did the harder ones. This is much easier. And this is the example of a tangent and a secant. Again, they're giving me the angle. They're looking for an arc. And you're going to plug it in. Angle equals 1/2 the big arc. Always look for the arc the furthest away. The further away, the bigger it gets, right? And this is much easier math, so I'm going to let it go from here. 24, which is the angle, equals the big arc, 118 minus the small arc. I would simply, now I'd multiply both sides by 2. And that's going to cancel these out, and I'm going to let you solve it from there. Okay? All right. I'm going to focus on this one, because this one gives me less numbers. Okay? And this requires you to think a little bit harder. Okay. This is going through the circle, so this is 2 secants. The formula is the same. The angle equals 1/2 the big arc minus the small arc. Okay, so we're going to plug in what we know. We know that this small arc, because it's pointing to x, is this arc. So that's going to go in for the small arc. Okay. What else we know is that this is the angle. It's pointing out here. So we're going to plug in the angle, which is 20 degrees. So looking at what we've got the angle and we've got one arc. What's missing is this outer arc. We're looking for the pink. So we do know that this piece is 130. And something that you're going to miss, but I really want you to try not to miss, is that we know that this is the diameter. How do we know it's the diameter? Because it's going through the center. And if this is the diameter, then we know it's going to cut off how many degrees? Yes, 180 degrees. So we know 180 degrees. So we got 180 degrees, we got 130 degrees. And we know this is x. How many total degrees are in a circle? correct, 360. So if we have a 360, and we know that this is half of it, minus 180. And we know that this is 130 degrees. We know that there's 50 degrees left. And that 50 degrees is this piece plus this piece. So if this is x, what's left? Well, this must be 50 minus x. Whatever x is, we know that if there's a total of 50 degrees left, that if this is x, then what's left over here is 50 minus x. So we're going to write this arc as 50 minus x. Now, it's no different than these other problems that I showed you where we had x's inside the circle, outside the circle, the actual angle itself. So now we have this one that we're working on. Again, 360 all the way around, minus what we know, 180. How do we know that this is 180? Because it goes through the diameter. We know that this is 130 because it's given to us. And we know that what's left must total 50 degrees. If this is x, then this piece out here is 50 minus x. And then we can simply plug it in and solve it. So this is 50 minus x minus x. So we end up with 20 degrees equals 1/2 50 minus an x and minus an x, that's minus 2 of those x's. And then multiply both sides by 2. All right, and 2 times 20 is 40. The halves cancel out because that's why we're doing it, and we end up with 50 minus 2x. And to get the x's alone, subtract 50 from both sides. We end up with, I'm going to take this over here, 40 minus 50 is negative 10. Negative 10 equals, this is a negative, negative 2x. Divide each side by negative 2, and we actually end up with a positive 5. Did I go too fast? Did I need to show this step? Negative 10 divided by negative 2 equals x. Okay, so don't be afraid. You could have moved the x to this side and the 40, and it's just as easy to divide both sides by a negative. Okay, now in your homework, you're going to get crazy looking problems that look like this one. Okay. Again, you've got to stop and look and say, hey, what do I know? Well, I do know this is a diameter. So we know that this piece is going to be how many degrees? 180. So we can look and see, hey, we know that this piece is 180. Be very, very careful in your homework. This 106 is not this little angle, it's this whole angle, which is inscribed on the circle. And that's this leg and this leg. So now we know that if this is 106 and it's on the circle, then this whole arc is how many times bigger? Twice as big as the 106. So we're going to get the green. The green minus the yellow is going to give you this leftover piece. And I'm not going to help you out any more than that. You really have to look at these problems and mark them down and figure out what is it that I know, and you're going to be applying all of the rules. We can't just use one new rule. We're going to end up putting them all together. And this little spinning wheel problem okay, is very similar to the Ferris wheel problem, where we ended up with seats on the Ferris wheel. Well, instead of seats, they said of each spook, it's not supposed to be spook, it's supposed to be spoke. That was a typo from Math Nation, so it's not a spook, it's a spoke, okay? And if each spoke intercept a 30-degree arc, meaning each one of these is how many degrees? That's right, 30 degrees. And where does it start? And where does it end? This is touching here. Okay, you don't start counting until you start moving. From here to here is 1, 2, 3, 4. Since this spoke comes from a central angle, they're really giving you a total degrees here. And what do we know about the angle and the arc? And that's as far as I'm going to give you. Okay? So when you go to start these problems, it's really, really important. You read through them, highlight the picture, apply previous things that we've learned before, like the Ferris wheel problem, and applying it to a clock or applying it to whatever situation we have. All right, guys, have a great day. Come hit me up for help online, 9:30 to 10:30, 11:30 to 12:30, and Mrs. Ogron will be on at 1 o'clock. Talk to you later.